Alright, hello chemistry class. Let's talk today about uncertainty in measurement. So really quickly, let's hit on accuracy and precision. Okay, accuracy is being able to get the correct measurement each time. Let's say we're measuring something and it's supposed to be 65 grams and that's the true value. Every time we measure it, we get 65 grams. That would have high accuracy because we're getting the correct number. Now, let's say there's some flaw in our scale. It had some, crud on it. It was weighing a little heavy, so we were getting consistently 67 grams for our measurement instead of 65. Now, that would still have horrible accuracy, but we'd have high precision because we're getting the same measurement each time. So our goal always to get high accuracy and high precision. Now, for the rest of this, the uncertainty part, let's talk about a hypothetical situation. So if I gave you a meter stick with no subdivisions or no markings on it besides you knew that it was 1 meter exactly, and told you to measure these floor tiles, how could you do that? Well, you'd have to estimate. You'd have to guess at where the marks are. So you might say 0.2, 0.3, even 0.4. You could say, since it's about 3 little floor tiles per meter stick, it's probably 0.3 plus or minus 0.1 meters. And that would be okay. So we're estimating 1 point. So I'm going to say it's 0.3. I've cheated because I've already gone ahead, but if we put those marks on, the tenth of a meter on, then we get here. Now you can see it's really pretty close to 0.3 meters. Each one of these marks is a tenth of a meter. There's 10 of them. And the mark for 0.3 meters was right about there. So now our measuring device is more precise. It's a better measuring device. Better than that stupid stick that's just a meter long, right? So we're still wanting to estimate one more digit. So let's take a closer look. So now if we look over here, you can see some of the marks through, but you can see that it's not quite 0.3. It's a little bit shy of that. So we could say maybe 0.29, 0.28. It looks to me like this would be 0.29. If we add in those marks again, now the original marks are the darker, so 0.1, 0.2, 0.3. And then we've further subdivided this meter stick up into centimeters, or tenth or hundredth of a meter. Now if you look at this, we can all agree that it's pretty close to 0.29. It's not 0.28. We can agree on that, but we're going to want to again estimate where that next digit is going to be. We always estimate. Always in science, we want to get as precise a measurement as we can, and we trust the human to actually estimate one more digit. So you would estimate here, you might say 0.298, 0.297, 0.299, depends on kind of your eye, and that little bit of variation is okay. So if we take a closer look, we want to always get the best estimate that we can. I'm going to go ahead and say 0.298. Okay, what about if the device had marks at half or a fourth? So this centimeter is divided, these centimeters are divided into half centimeters. So it's 29, 29 and a half, and 30. It doesn't really help us. It does make it easier because we know, well, it's easily between 0.295 and 0.30. We're not exactly sure. So these half marks or 1/4 marks that you might see, they're not really going to help us estimate one more point. So now with all of the marks on there, we can agree that it's 0.298, or at least really close to that. You might say 0.2979 or 0.2981, but my final estimate was 0.2980 meters or 29.80 centimeters. Either way, I hope you get the idea that we're always estimating one place past the measuring device that we have. So if our device can only measure to the 10th of a meter, we're going to estimate the 100th place. If we can only estimate, if our device only goes to 1 meter, we'd estimate to the 10th of a meter. Always estimating that one place. And in fact, this happens with all measurements, whether it's a graduated cylinder or an electronic balance. So in fact, the graduated balance, electronic balances that we'll use a lot in class are always estimating for you. That last place on the scale is actually the machine's estimate. Sometimes you'll see it flicker between a couple of different numbers. Usually it'll kind of settle down and decide on which one it wants. So this is always occurring, and we're going to represent it certain ways with significant digits. So I'd suggest you go ahead and watch the significant digit video and continue on. Thanks a lot. Hope you learned something, and I'll see you in class. Bye.